Hi everyone, I'd like to welcome you to Edgecore SONIC Solutions for Open Networking in the Cloud, together with Edgecore Networks and the Open Compute Project. My name is Ciara McCarthy. I'm the Global Marketing Director for EPS Global. So this is the 9th episode in our webinar series called It's Open Networking. You can access our past webinars and sign up for our future ones here on our Bright Talk channel. We've people on today from all across the US, Europe, Africa, the Middle East, Peru, India, Taiwan, Indonesia, and that's just to name some of the places. You're all very welcome and thank you for joining us today. So to kick off, I'd like to introduce you to our speakers for today. I'll start with Barry McGinley. Barry works for EPS Global. He is our systems engineer for EMEA. He primarily works on proof of concepts for data center, service provider, and enterprise deployments. I'll actually show everybody so everybody can say a quick hello. Barry, he works on POCs for data center, service provider, and enterprise deployments, and he leads the adoption of new bare metal hardware for carrier and telecom solutions available. So he provides the first layer of tech support for our customers, and he has an in-depth expertise of the open networking landscape, covering all of the open source software and hardware options. Barry's based in Dublin, Ireland, same as myself. He's the author of a very popular tech blog on our website at epsglobal.com. He'd also like me to add that he's also an avid Celtic supporter and enjoys a pint of Guinness. So joining us today also is Michael Ward. He's the VP of Business Development Software for Edgecore Networks. In this role, he is responsible for the software solutions to enable customers with choice in open networking from Edgecore's third-party NOS partnerships, as well as open source software offerings such as Sonic and Dent. Michael represents Edgecore on the board of the Linux Foundation's Dent project. He has held a variety of positions in the networking software space at companies including IBM, LVL7 Systems, Lenovo, and Broadcom. Also with us today is Steve Helvie from the OCP. Steve is a VP of Channel Development for the Open Compute Project. In his role, he helps to educate organizations on the benefits of open hardware designs and the value of community-driven engineering for the data center. As a strong advocate of open source and circular economy business models, he works closely with solution providers and manufacturers to drive adoption of OCP with the focus on sustainable, scalable infrastructure. So if everyone wants to give a quick wave, and I'll turn back on the slides. So just to give you a bit of information about EPS for anybody who doesn't know us, we specialize in open networking solutions that help businesses take control over how they configure and scale their networks using bare metal hardware that's more cost effective to buy and it's more efficient to run. We have all of the hardware, software, and technical resources to help you deploy open, disaggregated, and standards-based solutions that deliver the high-quality connectivity that your customers demand, all while delivering you cost savings. We've 28 global locations and we carry stock so you can save yourself the time and money, not to mention the hassle of dealing with multiple vendors and delivery timelines. We're also a member of the Open Compute Project and a solution provider on their marketplace. So with that, I would like to hand you over to Barry McGinley from EPS.
Thanks, Ciara, for the lovely introduction. I haven't had a pint of Guinness and I don't know when, actually. It'll probably be another 3 or 4 months. But thanks, everybody, for joining us today, whether it's morning, afternoon, or evening. So I'm Barry. I'm a network engineer with EPS, primarily working in open networking, as Ciara said. And what we're going to have a look at today, quick intro into EPS and what we actually do in open networking. I will have a look at the state of open networking from last year and have a look into 2021, the origins of SONIC and SAI, which is the switch abstraction interface. Then Mike will take us through Edgecore SONIC solution, the use cases, and then Steve will have a look at the OCP ecosystem, and we'll finish up with a Q&A, obviously, time dependent. Okay, so EPS. So Ciara said we're about 21 years old, but since 2013, we've been involved in open networking, and that came about because we became distributors for Edgecore Networks. But it was very early in open networking, and we had to start evangelizing and educating people about what open networking was about. And as well, the second part of that is the hardware is only one part of it. We had to start talking to the NOS vendors. So you'll see some of them there on the left-hand side. So we'd talk with PK, we'd work with PK8 quite a lot. Pluribus Networks, so Pluribus have an adaptive cloud fabric, an adaptive monitoring fabric, lab automation solution as well. IP and Fusion are mainly based in the telco now. They still have a data center solution. Down the bottom there, you see Volta and Exaware, their routing softwares. RT Brick and NetElastic, again, routing with a more on the virtual broadband network gateway. Netris and Abstract are orchestration and automation platforms. Kaloom is P4, and that is only a snapshot of the software. So it can get a little daunting, I suppose. So, and that's where we come in. So we provide turnkey solutions. So for both the software vendors and our customers. So when people are looking in at open networking, they see 20 operating systems. They see a heap of hardware manufacturers, which software works with which transceivers are then interoperable with the hardware. We take all that hassle out of it. So we'll install the NOSes for both the NOS vendors and the customer, do the licensing, bundling transceivers. So basically the switches are ready to slide into a rack, which definitely takes some of the pain out of open networking. So successes in 2020, the telco market, massive success through the Telecom Infra project and the ONF. So cell site routers, I think AT&T are installing 60,000 of these in their network. And again, it's the software that kind of makes this. Obviously, the boxes are great. Don't get me wrong. Edgecore, Eufy Space, a couple of guys making them, but software from Adva, Infinera, Volta, IP and Fusion, Exaware. There's a long list, and they all have their own little niche area. Open transponders, the Cassini is from Edgecore again, with IP and Fusion's OCNOS sitting on it. So we have few implementations of that in the States, some in South America, Africa, and Europe. And then edge and aggregation. We've been waiting on this edge that everyone's been talking about for a long time now, and it's starting. We thought 2020 was going to be the big year for it, but we have the software, which is important, and we have the hardware. So that's starting to move. So 2021 should be a big year there. The next area is 400 gig. It's slow, but we started to see adoption of 400 gig last year. And then this is quite interesting, actually, moving into retail and campus and enterprise networks with Dent. So I think it's the last area open networking hasn't really been successful in. There have been successes. PK8 have had some success there. And I know Cumulus, at the start of 2020, we're looking at campus Cumulus networks. Basically, their data center customers had asked them, they use Ansible in the data center, and they wanted to use the same in their campus network. So they went off and built the features they require, because you don't use spanning tree, port security, and multi-gigabit. So they added all of that, but obviously Cumulus were acquired by Mellanox NVIDIA, so it seemed to die a bit of a death. But then Dent was released in December of this year. So Dent is an open source operating system from the Linux Foundation. Amazon, of all people, are involved, who aren't very well known for their kind of collaborative, cooperative way of doing stuff. So Amazon, Edgecore, Marvell, switch ASIC manufacturer, Mellanox, and as well, one of the problems with retail and campus was that the 1 gig switches, and primarily 1 gig is used in campus and retail with 10 gig aggregation, they were too expensive. So the 1 gig switch and then put a NOS on top of it, and ended up far too expensive. So there's now a new switching range using Marvell switching ASICs, which are very cost friendly, and then with an open source operating system on it, it could be a really good solution for next year. The first version of that, incidentally, is called Arthur Dent, after the main protagonist from The Hitchhiker's Guide to the Galaxy. So routing software and hardware maturity. Again, the hardware was here, but we're kind of waiting on the software, and the same guys that are doing the cell site routers are here. And yeah, it was towards the end of last year starting to be quite successful, and we have all the areas of routing now. So core routing, aggregation, edge, peering, and so on and so forth. Some other successes: fiber to the home, fiber to the everything. So obviously governments globally are throwing money at people to build networks to provide gigabit broadband, and that's been a big success last year and will continue to be in open networking. Open line systems, some really good companies out there. Smart Optics are one for DCI interconnect or metro networks, or Open Road M's, lab automation, Pluribus. I think our next webinar is actually with Pluribus Networks on lab automation, monitoring and analytics, and basically every single one of these could be a webinar in itself. And this is only scratching the surface of the solutions and possibilities that are out there. So challenges in 2020. There was nobody home basically all year, so there was nobody in the data center. So a lot of projects were on hold. We're expecting a big year out of data center in open networking, but it didn't transpire. I was delivering most of the stuff to people's houses in EMEA over the last year. The second part is one size does not fit all. And I suppose this comes down to education and about open networking. So I think people can take a liking to a specific software and it may not actually fit their needs. So it's up to us, I suppose, to figure out solutions that will fit their needs properly. And as well, I suppose Sonic is something we're looking at that may end up be a one size fits all for the data center, but at the minute, that's not the case with open networking. And then finally, acquisitions. So Cumulus Networks were bought by Mellanox NVIDIA, Big Switch Networks were bought by Arista, and Apstra was recently bought by Juniper Networks. And I suppose you can look at this two ways. You can say it shows the success of open networking, that these guys are being bought for a pretty penny, but it also erodes a bit of confidence in open networking. So guys say they did Edgecore and Cumulus deployment, and a couple of months later, they're told you'll still have your support contract, but it's not what they got into. They got into it for open networking, and now they don't feel like they are. So there's never been a better time for Sonic, basically. The gap was filled with Sonic, and the gap has been quickly filled for Big Switch Networks as well by Pluribus. Apstra are still being sold to third parties, I think, but there's another company, Netris, there. So it won't take long for the gap to be filled, but this brings us on to Sonic. So very high level overview of Sonic. So it stands for Software for Open Networking in the Cloud. It was created by Microsoft for their Azure sites and gifted to the OCP in 2017. I think it's about 2015 it's been working in Microsoft Azure. It's adopted by Alibaba, Tencent, LinkedIn, and so on. 3.9 million Ethernet ports and growing fast. I think that stat is from maybe April of last year, so considerably higher now. There's a mix of silicon technologies, and Sonic is built upon the switch abstraction interface. I'm going to explain both of them in a little bit more detail now, after I just look at the community. So this is the community. You have Microsoft and Broadcom as the biggest contributors, which makes sense. Obviously, Microsoft would be. And as you go down, then you have Dell, Mellanox, Edgecore, and you can add the Acton group further up into the Edgecore one. And you have Dell, Mellanox, and Edgecore kind of level on their contributions to the community. So, and as you go around the wheel, you'll see Barefoot, who've been bought by Intel, Centec, Inventec, LinkedIn, and Alibaba. So these are the two. So when Microsoft built this, they built a very specific use case in their data center, and then they built upon it. And when they gifted it to the OCP, each added feature they put into the repository in GitHub. But LinkedIn and Alibaba did the same. So at each deployment, you're getting to a critical mass, basically, of features. And this is where we're at, or it's where we were at a while back, and why we have options from Edgecore and our open source option as well. Okay, so I'll finish up quickly just about the switch abstraction interface, because it's a very important part of why this has been a success and why it's going to be a big success. So it was an open OCP project, so OCP very prevalent in all of this, by Microsoft, Intel, and Mellanox, I think around 2015 as well. So it defines the API for a vendor-independent way of controlling forwarding elements. So your switching ASIC, basically. And I'll explain this in an image now in a minute. So prior to this, software vendors had to integrate their NOS into the switching ASIC using the software development kit. So Cumulus and Broadcom would have to work very closely together to get Cumulus's NOS working on the switching ASIC, with the switching ASIC. So we have chip options from Broadcom, Mellanox, Marvell, Cavium, so on and so forth. And I'll explain what I mean by that now. So This is the way it was done. So we've hardware. So we've say we're going to use an Edgecore box with a Broadcom switching ASIC, say the Trident 2 or something. And now we're getting into the software stack with our ASIC driver, our ASIC SDK, and then say our Cumulus NOS on top. So Cumulus and Broadcom now have to work together to get that NOS to work with the switching ASIC. And then when they're finished, Cumulus have to go and do it with Mellanox. And when they're finished that, they have to go and do it with Marvell. So every single switch, they have to do the same thing. So what the switch abstraction interface allows is, again, we have our hardware. So we're going to say it's a Broadcom ASIC, but it doesn't matter what ASIC it is. And above that, we're getting into our stack. So our ASIC driver, our ASIC SDK, and this is the standard interface. So it doesn't matter what the switching ASIC underneath is. It can be, as I said, Broadcom, Mellanox, Marvell, and then above we have our NOS. So the SAI, as we call it, is the southbound interface for the NOS. It's as simple as that, and that's why the time to market has been absolutely slashed for open source NOSes like Sonic. So basically every piece of hardware that comes out now is Sonic ready. And we've seen, I think it's up to, the last time I looked, maybe 110 hardware devices for Sonic, and everything new that comes out will be Sonic ready. So that's all from me for the minute. I'll hand you over to Mike from Edgecore.
Great, thanks, Barry.
Yes.
Hopefully everyone can hear me. Thanks, Barry. We'll move on now into the area of Sonic. So just briefly, for those who may not be familiar with Edgecore, I wanted to provide a short introduction. Edgecore is a leader in the open disaggregated networking space, and we offer a full portfolio of both open networking as well as traditional networking platforms. And we're a subsidiary of the Acton Group, headquartered in Taiwan, with offices in the US, Asia, Europe, and then have worldwide sales and support coverage. As we look at areas where Edgecore is participating, and really our commitment into the open networking domain, we see the open communities as a critical part of our success and how we go about going to market. We have been involved heavily in multiple aspects of the Open Compute project, both from projects such as Sonic, as we're discussing here today, but also contributions of hardware designs to facilitate the Open Compute project's mission in terms of driving open networking. We've been heavily involved in multiple projects, both on the software and hardware side of the Open Network Foundation, more service provider centric, as well as the Telecom Member project. And then, as Barry mentioned here more recently, have gotten involved with the DENT project from the Linux Foundation, which is now focused more into the distributed enterprise space. We work very closely with numerous open networking NOS providers and have over 20 proven commercial software options from our software partners that are pre-integrated and validated on the Edgecore solutions. And in 2020 alone, we shipped over 9 million ports into the market. So very committed into this space and have seen a lot of success driving forward of open networking and driving things into this domain. So we're really seeing a revolution in the space of networking over the last several years here. Really, it's a fundamental change in the way the industry is producing products, consuming, and operating products for the network. And we ask ourselves, why? What are the real tenets that are driving this transition and this sort of paradigm shift? And it boils down to three key factors. The first is freedom. Our customers are saying they're looking for freedom from vendor lock-in. They're frustrated with the traditional OEM engagement models where they get locked into a particular architecture, and as our customers' needs change, or have new requirements, desires to deliver new services, they're fixed into that particular OEM's vision of the network and are locked into that scenario. Our customers are looking to deploy innovation at rapid paces beyond what we've seen in years. The need to deploy new services, situations here over the last year like COVID, which has just dramatically and exponentially increased the need for broadband. It really is driving the need for new services and solutions and applications into the network. And our customers cannot wait on the long cycles that come from traditional development models. And that ties into the third tenet, which is that of control. The customer's desire to control how their network operates and ensure that it's tailored to what's important to them. The particular set of features or the applications or the visibility that they care about into their network and being able to deliver that. And these are really tenets that just have not aligned well with the traditional approach, and has been fostering and driving customers to look at open source-based solutions in the open networking domain. And that leads us in today into the conversation of SONIC. So Barry touched on some of the high level of SONIC of what it is, software for open networking in the cloud. And it is, again, of course, fundamentally a solution that was developed initially at Microsoft and provided into the open project into the community as a whole. It is a sort of a more modern software architecture for the NOS that breaks up the traditional monolithic switch software into multiple containerized components. And this lends itself into a number of different benefits. One of the first benefits is the fact that it provides for more fine-grained failure recovery and in-service upgrades with zero downtime. The ability to reload the routing stack container while the management containers or management applications or the other forwarding plane applications still execute. These really provide that higher level of benefit. It also opens up, and this is, I think, really a key important benefit to SONIC, it opens up the concept of plug-in components or additional applications to tailor to a customer-specific scenario. These applications may come from a third-party provider. They may be obviously proprietary, or they might be open-sourced. There may be open-source projects that can be developed and integrated in, or it may be something a customer develops in-house and brings in to meet their specific needs. There are a number of parties that are emerging into the ecosystem, building applications to fit onto the top of SONIC. I think about SONIC in a way analogous to perhaps Microsoft Windows. You have Linux underneath as the core basic operating system, analogous to DOS or something underneath there. Then you have the SONIC framework, which is analogous to Windows. And when you purchase Windows, it comes with a collection of applications, just as SONIC comes with applications from the routing protocols, FRR, as an example, and other pieces that make up that delivery of that solution. But you as the end user can add and either purchase, develop, or add additional applications on top of that, really giving you the flexibility to drive that aspect of control into your network. And then finally, Barry did a great job covering the value of the SAI Abstraction interface that SONIC sits upon, which gives it the independence and really helps drive the openness of open networking for portability across different platforms. So as a network operator, standardize on SONIC in different aspects of your network and build orchestration and management solutions around that, you're able to pick the best of breed technology for the different devices that need to sit in different roles within your network, but still manage and have that common application interface at the upper level. So Edgecore has come to market really embracing SONIC to help drive forward the open networking space in the data center and then growing into other sectors. Apologies. We have brought forward a open but yet production ready and commercially deployable distribution of SONIC, of the community-based SONIC. And the goal of that is to really help our customers rapidly deploy SONIC on open networking hardware and realize those benefits. This is a version that is derived directly and very closely linked and stays in tight linkage with the community distribution, but does include some enhancements and modifications. They may be bug fixes from the additional testing that we do, we'll talk more about in a moment, or they may be additional feature value adds that are being added to address specific customer requirements or things that are making their way eventually into the community side, but there's a sort of a need to accelerate to the customers. SONIC is fundamentally targeted to the data center, where it grew out of, obviously, from Microsoft. That said, we're seeing pull SONIC into many different applications all over into the service provider telco segment, as well as the enterprise in other areas. And we'll talk about some of those use cases where SONIC is well suited today, and then where it's headed in a few moments. And then lastly, the solution that Edgecore offers also has integrations with third-party orchestration solutions. One example mentioned earlier was this orchestration offering from Abstraction. It really allows customers to take best-of-breed technologies, leveraging an open-source foundation, but then really manage a homogeneous network using solutions like Abstraction. So really at the core tenet of one core aspect value, sorry, it's not getting a lag on loading in content. I apologize. I want to pull that in. One real key aspect of the value proposition of the solution, SONIC solution from Edgecore, is the additional level of hardening and testing that the offering we provide has. It's sort of just a classic challenge with open source community projects in that they can only receive a certain level of validation, and they're kind of covering a broad brush across a wide set of offerings. It's sort of interesting aspect to think about sort of the difference that comes into play with networking solutions, open networking, open community projects for networking versus those on the server side. Applications that may be running on a server exist in a much more unified or consistent environment. An x86 processor, more aligned and contained versions of Linux, and so forth. Whereas in the networking space, we have a much wider diversity of switching silicon, the switching vendor hardware platforms, Edgecore or other vendors, and just how all those pieces kind of come together. So it makes for a much more challenging testing environment for a community-based project. So that's where Edgecore is worked to sort of bring that to the next level, bringing that distribution in and really taking it through a much more robust, expanded test suite with automated and manual testing that goes on to ensure that what comes out the back end of that is something that is ready for full production deployment, with testing that has occurred not just on the hardware platform, but also with the breadth of optics and pluggable modules, cables that go as part of the overall system, so that you can have confidence in deploying it at a system level into your network. So let's dive into some of the use cases. And first, we're going to focus on sort of what was the foundational use case of SONIC, which was that of a scalable L3 fabric underlay. So I apologize, something weird going on the slide, just enhancements here. Get these built back in. So fundamentally, the initial use case for SONIC was that of a cloth-based architecture, leaf spine type fabric using BGP. And BGP has been well proven out to allow for a scale-out architecture and allow you to sort of take a simple, repeatable configuration, build sort of cookie-cutter pods or building blocks, and expand your network as you need, as your needs grow. And this is obviously being deployed in hyperscale environments today, and is very well proven and works as a new network fabric, if you will. The next space we can look through is now into where it has expanded into expanding that fabric now into multiple tenants or multiple end users, being able to overlay L2 domains into using this BGP fabric. And by the expansion of SONIC to now include multi-tenancy through VXLAN and EVPN protocols, there's the ability now to have a much larger namespace than traditional VLANs provide, and it helps future-proof you. So now you have the ability to take advantage and build upon that highly scalable, resilient BGP-based fabric, and now deploy it to whether it be multiple tenants in a service provider environment, or it may be just different work groups within more of an enterprise scenario, or multiple customer applications. Couple that with features such as MC lag, you now have a even further increased layer of resiliency from your servers into your fabric. So really drives a new level of functionality into the SONIC domain. Now, we talk about SONIC being focused in the data center, and it was born out of the hyperscale kind of environments. So does that mean SONIC only applies and can only live in the big hyperscale data centers? And the answer there is no. But we do need to certainly be realistic and careful about where we're positioning and placing SONIC. I think a very interesting opportunity for SONIC is in looking at a new enterprise network. Moving away from some of the legacy protocols and a lot of the ring-based protocols and a lot of the proprietary OEM-centric protocols, and taking advantage of this highly proven, highly scalable network from the data center and deploying it into the enterprise, perhaps first as the enterprise data center, but then pushing it downwards into other aspects of the campus. Now, it's fair to say that today, SONIC does not have all the features and support necessary to fully address the access layer. But we constantly see contributions from members in the community driving and pushing things into that space. And I think as we look forward a few years, I think we fully expect to see SONIC sort of help to fill the voids into that side. But sitting today, SONIC is really a great opportunity to fulfill the certainly your data center use cases, and that may be your data center in the enterprise, or even a service provider, or telco type data center, and using that as a fabric or perhaps the connectivity mechanism for maybe the campus core network, to then where you layer on the edge of that your traditional access type switches. Then I want to spend a few minutes talking about management of these solutions. And I think this is a very interesting aspect of SONIC. Again, SONIC being born from a very large-scale environment, it has at its foundation support for DevOps and API programmatic-based interfaces. The ability to integrate into things like Chef and Puppet and Ansible to help monitor, manage, and configure your network is really sort of a core part of that automation. But for customers at a smaller scale, they may not have a network that's of a scale that warrants their investment in those DevOps or those automation-based interfaces. And therefore, they may want just a traditional management, whether that be through a CLI or SNMP interfaces or otherwise. And those exist. SONIC itself has a number of CLIs based on the individual applications. FRR has its CLI for its interface, and other applications have their own respective pieces. But one of the additional value adds from the Edgecore-based SONIC solutions is the ability to provide a unified CLI that is what I'll call industry standard and familiar to most network operators that have used major OEM networking equipment. So this is certainly a benefit where now there's a single common CLI, and you don't have to learn the FRR CLI and the CLI that's different for VLANs and how do I configure an interface in a Linux. You have a very common CLI to drive the overall solution. Again, for customers that don't have the scale of their network to really drive out a full-blown DevOps kind of infrastructure, this can certainly be a good opportunity. And finally, in this domain, SONIC is very rapidly expanding in the area of telemetry and analytics into the device, the ability to have a higher level of visibility into your network. And this is coming both from features that are being enabled within SONIC itself, but also third-party applications that are coming forward to integrate with SONIC to help expose and extract and collect that information and make sense of that to present it to you in a meaningful manner. So this is certainly a very interesting area that's emerging, and one that I think where SONIC will have a lot of value going forward. So let's now talk about the supported platforms. SONIC, typically we see customers deploying SONIC as their data fabric. So the 1025 gig switches for the leaf switches, and then the 100 or 400 gig for the spine, super spine applications. And we have a number of choices in each of those each of those roles that can play there across the portfolio. And as Barry mentioned earlier, as we go forward and introduce new products into these segments, they will be supporting SONIC going forward. We have also had a lot of customers come to us and say, if I'm going to standardize on SONIC for my data fabric, it sure would be nice to be able to use SONIC on my management network. I'm not going to be doing routing there, but if I'm going to invest in some infrastructure to manage an interface to the SONIC APIs to manage and configure and monitor those devices, it'd be nice to have the same interfaces and talk to the management switches. So we've also extended this support now into our 1 gig switches, support on multiple devices in the 4630 family, and this is going to be expanding here shortly as we go through the first half and into summertime of 2021 to provide additional options, including some even lower cost management switch options in this domain. So we talked a lot about the importance of the hardening of SONIC, but taking the community and hardening it. And one of the key issues that comes up from customers in conversation is, okay, this is great. Who's going to support it on the back end? If at 2 in the morning there's a problem, I can't post something on the forum and expect a response to get my network back up and running. And that's where what Edgecore is helping to solve here is by providing a top-to-bottom full-stack support for SONIC. At the end of the day, you call Edgecore for support on the SONIC solutions on our hardware, and we resolve that problem for you. If it's a configuration question, we'll work with you to provide the information you need. If there happens to be a hardware-related problem, we certainly take care of that side. And then if it does turn into be a software-related issue somewhere within the SONIC domain, regardless of if it's a platform driver or something in the networking in the side layer or all the way up into the routing protocols or other SONIC applications, Edgecore is on the hook to take care of that and resolve that issue for you and get a patch and things moving forward, or just work with you on the network architecture and configuration aspects. So it really becomes the ability, one vendor that can help solve that, but keeping you within the confines of the open aspect of a open networking, open source based solution that continues to give you those options. So I think that's certainly a very important part. So I want to wrap up here sort of re-emphasizing again the value that the combined Edgecore and offerings with SONIC provide. I think we all benefit from the fact that we're working with an open source, community sourced solution that has been now hardened on top of the Edgecore specific platforms. We have the benefit of a worldwide community of developers driving expertise from all different areas into the solution and enhancing and continue to push SONIC forward into new domains. But we're able to take that and then ensure what you get from there is something that works, something that's hardened and validated and works in your particular use cases and can be deployed with confidence. We're working with a solution that has been traditionally tailored for data center and proven into very large scale data centers. So I think that delivers a value to customers who aren't, even those that aren't building a mega scale data center, right? You have the confidence knowing that the software behind it can run at scale, run at those levels of performance. So you can have confidence that it will certainly meet your needs in a smaller environment. And also, as we just talked to the support side, you have the ability to not have to worry about chasing down multiple vendors on hardware versus software issues. You come to Edgecore, we'll solve that issue for you. And then finally, and last but not least, working with Edgecore and SONIC really gives you the fastest time to market for SONIC on the Edgecore platforms by delivering by integrating SONIC on the platforms as we're still in the early phases of the hardware development, testing those throughout the process such that when we introduce a new platform that's targeted to these markets, SONIC is there and in production form ready to go. And it really helps you stay on the forefront of the speed and feed side of things while benefiting from all the value that SONIC itself brings. So with that, I'm going to pass it on over to Steve to talk about some of the updates from the open compute side and where SONIC plays there.
Thank you, Michael. I appreciate that, and thanks, Barry, for the update on the overall market. The growth of open networking is going to be substantial over the next couple of years, and SONIC is going to be one of those factors that leads to that growth. And most of the growth is going to be driven by communities, the activity that's happening inside the community. So it's not just open compute, it's O&F, it's the Telco Infrastructure Project, it's the O-RAN Alliance. There are other open source communities out there that are going to help drive this number up to the 1.3. And there's no shortage of information out there about SONIC and all the people that are starting to adopt it. One thing that's great about open compute is that it takes a look at the hardware layer in addition to the software. So as Barry alluded to, SONIC was contributed to open compute back in 2015 and 2017 from Microsoft. And the great thing about Edgecore is that they've also open sourced the designs of their switches. So you get a full open solution with a specification, design files, all the way up to the software layer. And that's really the genesis of open compute, is when you take that white box piece of hardware and you open source it through a specification and a design file. That created the Open Compute Project. So the Open Compute Project is over 200 companies, over 8,000 engineers working across common problems in the data centers. We have 25 projects. One of those sub-projects is SONIC, and I'll get to that in just a minute. But this is really where a lot of the work happens, is getting involved 8,000 engineers from all different types of companies worldwide. Now, there are four things that drive everything we do within Open Compute: efficiency, growth, scale, and openness. So if a contribution, if you see something on our website, it has to meet these four tenets, and they have to demonstrate those four tenets to the technical steering committee. And certainly Edgecore has demonstrated this not only in their products, but also through their leadership. As Michael had mentioned, and Barry, that Edgecore not only contributes their hardware designs, but they also lead a couple of these projects, as well as sit on our technical steering committees. So let's talk about the ecosystem. There's two key areas I want to talk to you about SONIC specifically. One is at the community angle. There is a sub-project within Open Compute that is dedicated to SONIC and SAI. So if you go on our website, you go under projects, under the networking project, you can see the SONIC and SAI sub-projects. You can join the mailing list. You can take a look at the wiki. They have monthly calls. You can join one of the working groups. There's over 10 working groups happening within SONIC. So I encourage you to take a look at some of the information out there, join the mailing list. All of the calls are recorded, so regardless of your time zone, you'll be able to listen in on those calls, either real time or on demand. The second key area around the community is, well, how do I get a sense of who all's involved in the community? What kind of products are out there? Well, certainly, Michael had mentioned the platforms that Edgecore currently has, but if you want a comprehensive view, you can go to our marketplace under products and integrated solutions, and we have tagged those solutions that are certified and validated on SONIC. And you also see integrated solutions, and this is just an example of a reference architecture that Edgecore put together around a 5G disaggregated network that's running SONIC and even runs Open Compute hardware at the cell site, as well as the aggregated edge and even the core data center. So you can check that out if that's of interest. And lastly, if you have the time, I encourage you to take a look at a session that was conducted back in May of 2020, and I've included the link here. And this is a SONIC dedicated session at the OCP Global Summit led by Microsoft with the following companies on a panel discussion, and they're all at different stages of implementing SONIC. And this was about, again, last May. So it'll give you a good idea about some of the challenges and how people are addressing moving SONIC into the enterprise. And with that, Barry, I will turn it back over to you.
Cheers, Steve. That was very informative, and thanks, Mike, as well. So just finishing up, some blogs there you might be interested in. There's one, my most recent one was on Dent and SONIC, Hitchhiker and the Hedgehog, data center fabrics and so on, and stuff on telcos, and one there on NOSes as well. As Kira alluded to it earlier, there's some monthly webinars. I think next up is Pluribus with the lab automation, and my contact details will go out. Kira and the marketing team will send on the PowerPoint to everybody. There is some questions there. I think Kira has some other questions, but I think Mike will take this one. But is Dent the Linux version of Sonic? If so, does Edgecore support that production integration? No, it's completely separate. I'll let Mike speak about it. I think Mike is on the board, are you? Did you say?
Sure. So I guess my answer to that would be, I don't know if I would say Dent is the Linux version of Sonic. Of course, Sonic is running on Linux as well. Dent is really fundamentally just focused on a different market space, more the enterprise domain, and it's taken a little different architecture, leveraging switch step. So from the Edgecore perspective, we do have devices that support Dent and are available today. At this time, Edgecore does not offer a production or a commercial support offering around Dent. We're still pretty early in the Dent life cycle. The first version of the Dent software was released just maybe 6 weeks ago or so now at this point in time. So that is something you can go download from the dent.dev website and load and run on the targeted Edgecore platforms. And we'll be monitoring and very actively participating in that as that goes forward and so forth. So I think I certainly see them both as having their spaces and their roles in the network.
Perfect. Thanks, Mike. We had a few other questions that we might fly through because we don't want to keep people on too long. Somebody asked, I know Sonic is used by the large hyperscalers, but is it something a regular enterprise can adopt? You may have covered this, guys, in your slides, but who'd like to take that one?
Yeah. Well, I'd hope so. Like, I have about 4 or 5 proof of concepts on in EMEA. So, but it goes back to what I was saying about the critical mass thing. We are at that point, but like every other inquiry we get for a NOS, we have to validate whether it'll work or not. But that goes for Cumulus, goes for IP Infusion's OCNOS. Yeah, so we are there, yeah.
And I would just add, Barry, that if you look at the contributors, you'll get a good sense of the type of enterprises that are trying to adopt this. So they're going to be pretty active. There were some pretty interesting enterprises that are contributing quite a bit. So that you know that they're working hard. If it's not enterprise ready 100% now, they're quickly moving that direction.
Perfect. Okay. Next question. How does the distribution available from Edgecore differ from what can be downloaded from the Community Hub?
So fundamentally, what we work to drive there is to keep the Edgecore distributions very closely in sync with the community. As mentioned, that there is the hardening that goes on, so there's multiple things that may happen there. One is fixing bugs that we may identify in our testing process, and at times there's some additional features that are being provided, and ultimately they're directed that will be headed towards the community-based version. I like to think of the distribution as sort of a production-ready preview of what will be to come in the community. There's a commitment that everything that is being enhanced on the distribution does go back to the community. 100% of that is headed back into the community. What none of us control directly is how quickly those changes may get directly in there. But it is intended to provide that back. So, customers that make the investment around that certainly can have confidence that there's still the alignment with what's happening in the community side as well.
Okay, yeah. Perfect.
I think as well, having one person to roar at, you need to be able to pick up the phone to somebody. So, and having Edgecore as the hardware and the software makes sense.
Okay, thanks, Barry and Mike. Kind of a big question. Where do you see Sonic going in the next year or two? I don't know who wants to take that, or if a couple of you want to.
Yeah, well, obviously we have to start all these deployments that we're talking about. I know Microsoft have big plans. They're looking at load balancing. They're looking at managing it with Kubernetes. They're looking at moving it out to the edge. So I suppose getting all the ones I'm doing anyway, getting the proof of concepts I'm doing up and running, and having success stories and sharing them with smaller guys. Not with your big guys, because they have multiple engineers to help work on this stuff. But the smaller guys, if we can see it working there, it should be a success.
Does anybody else?
I agree. I'll echo to that again. I think where we see traction at the moment is customers who have use cases that are aligned to where the core Sonic use cases fit the BGP fabric underlays, or expanding that into multi-tenancy. That said, where is it going to go? We talk to customers daily that want to pull SONIC into every different direction, from telco service provider to enterprise to access to you name it. So I think, it's really going to come down to what the community does and those that get active and involved in the SONIC community and what they help contribute and participate into that domain. I think it's sort of a natural evolution for SONIC to sort of trickle its way down from the data, as I mentioned earlier, from the larger scale data centers and the enterprise data centers, and work its way down the stack, if you will, to the, eventually towards the access space. And then those sort of peering roles in other segments of telco and so forth.
Okay. We have a couple of quite technical questions, which, Barry, maybe I can ask you to follow up with the people afterwards. There was a kind of a general question. Can you share the location of the SONIC blogs? That's on our website at epsglobal.com. What we've done is we've made some of the links to those blogs that were shown on screen, I think are available in the content section alongside this webinar, and we can send them out to all webinar attendees after it, along with the recording and the slide deck, if that would help. Okay, I think that the technical questions, guys, we can get to after, if that's okay. And okay, so we're going to wrap it up there. Thanks a million to everybody who joined us. We really appreciate your time. I think it was some really good insight into the current state of affairs and open networking landscape and where SONIC is headed, the feature set, and updates from the OCP as well. So we hope to see you at our next webinar, which is with Pluribus on March 10th on lab automation. And then, we've a lot of them you'll see on our channel anyway. So thanks again, guys, and thank you to our speakers today. That was really helpful and insightful.
Thank you, everyone.
Thank you.
Thanks, guys.
Cheers.
Thank you. Bye. Bye.